Hola, buenas tardes. Bienvenidos al Planetario de Madrid. Sube un poquitito el volumen. Sube un poquitito el volumen. Bueno, como sabéis, todos los años en otoño organizamos un ciclo de conferencias que llamamos últimamente singularities. Y en esta ocasión pues hemos querido traer como inicio del ciclo pues una conferencia muy interesante de un astrofísico polaco. También sabéis que el Planetario de Madrid ya ha trabajado en colaboración con la Embajada de Polonia y con el Instituto Polaco de Cultura. El año pasado, de hecho, tuvimos un ciclo de películas de Stanisław Lem para celebrar el aniversario, uno de sus aniversarios. Y este año también, con motivo del aniversario de Nicolás Copérnico, uno de los más importantes astrónomos de toda la historia de la humanidad, que como sabéis fue el que propuso el modelo heliocéntrico, en el cual sacaba a la Tierra del centro del universo y colocaba a aquel universo que se conocía en aquel momento, se colocó al Sol en el centro del universo. Y con motivo de este acontecimiento, Copérnico nació en Torun, que además precisamente es uno de los lugares donde ha trabajado nuestro invitado. Pues queríamos realizar esta conferencia. Él ha venido ex profeso para esta charla tan interesante. Y ahora también quería agradecer, aparte de agradecer a Claudia y a Ernest por su trabajo impresionante en toda la organización del evento y de todas las cosas que además luego veréis, que tenemos una pequeña exposición sobre el Casino Copérnico, que se llama. Tenemos el honor de tener con nosotros aquí a la embajadora de Polonia en España y que os va a dirigir unas palabras de bienvenida también y de agradecimiento porque hayáis venido y porque queráis participar de todas estas actividades que con mucho gusto el Planetario de Madrid hace en colaboración con otros centros. Así que, por favor, Ana, os va a dirigir unas palabras.
Muchas gracias. Es un placer para mí darles la bienvenida al acto que Embajada de Polonia y el Instituto Polaco de Cultura organizan con motivo del año de Copérnico. En primer lugar, quería dar las gracias al Planetario de Madrid por acogernos en su sede y por su apoyo a este proyecto. Hoy tendremos la oportunidad de escuchar una conferencia de Jan Świerkowski, astrónomo y doctor en ciencias de la cultura. Jan Świerkowski ha sido, entre otros, comisario de la exposición Comprendiendo el Universo en el pabellón de Polonia durante Expo 2020 en Dubái. Es también fundador del colectivo artístico Instytut B61, Instituto B61, que combina la ciencia con el arte. Gracias a la colaboración con el Instituto B61, hemos llevado al Planetario de Madrid la exposición interactiva Casino Copernicus. La exposición consiste en juegos educativos relacionados con la exploración especial y es una experiencia realmente extraordinaria, o eso creemos por lo menos. Les animo muchísimo a visitar esta exposición y espero que disfruten de la conferencia. Muchas gracias.
Bueno, muchas gracias, Ana. Algún pequeño comentario más de su currículum. Él es licenciado en astrofísica por la Facultad de Física, Astronomía e Informática Aplicada de la Universidad Nicolás Copérnicos de Torun, que es el lugar de nacimiento de Copérnico. Hizo su doctorado en estudios culturales en la Universidad Católica Portuguesa de Lisboa y la Universidad de Copenhague como parte de un programa individual de estudios de humanidades. Ha sido becario del programa del gobierno portugués para científicos FCT y del Ministerio Polaco de Cultura y Patrimonio Nacional. Es también embajador honorario de la Universidad Nicolás Copérnicos de Torun y ganador del premio del Ministerio de Ciencia y Educación Superior Popularizador de la Ciencia en Polonia 2017, miembro del Consejo del Programa de Estrategia Cultural de Torun para los años 2011 hasta el 2020 y coordinador de proyectos especiales en la Embajada de la República de Polonia en Lisboa. Es también presidente del clúster creativo de Cuyavia y Pomerania e investigador del Centro de Comunicación y Cultura de Lisboa. Sus trabajos científicos y artísticos han sido mostrados en Polonia, Bélgica, Holanda, India, Alemania y Portugal, por supuesto. Y como comentaba la embajadora, pues ha sido comisario de la exposición Comprendiendo el Universo en el pabellón de Polonia de la Expo 2020 en Dubái. La conferencia es en inglés. Él comentaba que le hubiera gustado hacerla en español, pero bueno, todavía el año que viene en español. Y bueno, pues os dejo con Jan Szurkowski. Muchas gracias, Jan, por venir y nada, todo tuyo.
Thank you so much for the kind words. Thank you so much, Miss Ambassador. Thank you so much, Telmo. Thank you for having me today. I will be talking a lot about science, but also art. I will be talking a lot about Copernicus, not only because he's an astronomer, just as I started my scientific career, but also, as it was mentioned, I come from Toruń, the city of Copernicus, and you have to know that in Toruń everything is about Copernicus. Astronomy, taxis, even if you go to buy a chocolate, it's called Copernicus. So I will be talking a little bit about Copernicus and how it came about that I became from an astrophysicist, a cultural researcher, most probably because, as you know, Copernican revolution doesn't only mean revolution in science, but also in culture. So let's go and let's start my talk today, which is titled The Cosmic Perspective. And as I said, we are gathered here because of him, Nicolaus Copernicus, an outstanding Polish astronomer, mathematician, and a doctor. And Copernicus was born in the 15th century in what was then an informal union between Poland and the Grand Duchy of Lithuania, which looked more or less like this. And he was born in Toruń, the city which hasn't changed for the last 500 years. But 500 years ago, it was one of the biggest cities in Europe, and Copernicus was born in that city and looked more or less like this. Now, he was an extremely well-educated man because he studied in Krakow at one of the oldest universities in Europe. He would study math, physics, astronomy there, but then he would travel to Italy and he would study at the University of Bologna, where he would study law. Then, obviously, he would study more. He would become a doctor after studying at the University of Padua. And finally, he would receive his doctorate in canon law from the University of Ferrara. Now, after completing his studies, Copernicus would come back to Poland and serve Poland for more than 40 years. And he would take part in various political, administrative, economic, and even military duties. However, of course, he is most known for his astronomical activities, focused on the predictions of the movements of planets, which he published in on the Revolutions of the Heavenly Spheres book in 1543, just before he died. And this book, like many other important books, was banned in 1616 by the Holy Inquisition. Now, what was so different in that book, or what was so revolutionary that it had to be banned? As most probably you know, Copernicus questioned the paradigm that lasted for thousands of years, that the Earth and the humans are in the center of everything. Now, we are so accustomed to the way that the solar system looks, and we of course all know, and we know how to visualize it, that I actually thought it would be useful to see the Ptolemaic geocentric system in a short animation.
In his efforts to come up with a model that would explain the movement of the planets across the night sky, the 2nd century Greek astronomer Ptolemy imagined the Earth sitting at the centre of existence. Around the Earth he placed the planets on a system of linked circles. The larger ones he called deferents, while the smaller ones were called epicycles. Ptolemy's model enabled astronomers to do a range of important things, including make sense of a strange celestial phenomenon called retrograde motion. This is where the planets appeared to stop and reverse along their paths for a little bit before continuing along their way. As Ptolemy's model explained it, the reason for this had to do with the independent rotation of the planets on the epicycle. If the speed of the rotation of the smaller circle was sufficient, there would be times when the paths of the planets would appear from Earth's perspective to go in reverse. For all of its usefulness, Ptolemy's theory was hugely complex, and the result was anything but elegant. In fact, to get the model to work at all, he had to imagine that the difference didn't orbit Earth directly, but an imaginary point offset to one side of the true centre, with Earth offset to the other. Only then would the apparent speed of the planetary motions work out correctly. As astronomers made increasingly precise measurements of planetary positions over time, the Ptolemaic model only seemed to become less and less satisfactory.
So this model prevailed for thousands of years, and Copernicus had a different idea, a completely different one, and most, or at least the most important observations of Copernicus still stand today, and obviously the most important one, that the Earth is one of several planets that revolve around the Sun, not the other way around. The Earth has three motions. The retrograde motion can be explained by the movement of the Earth and not the movement of the planets. And the distance from the Earth to the Sun is far smaller than the distance from the Sun to the stars. Now let's see the two systems on one animation. On the left, obviously, the geocentric system, and the Sun on the right. Now, obviously, you can see one is extremely complicated, and the other one, the simplified version, looks very simplistic. But somehow humans would stick to the one which is more complicated. Do you have any idea why and what for? Obviously, the complicated one had not only Earth, but also us in the middle of everything. So that was the thing. Even though the answer was quite simple, we would rather come up with very complicated solutions to why we are here, other than accept the fact that we are not the center of everything, right? So this is the real reason that we would not discuss the proper scientific solution for so many years, right? We kept and we wanted to be the center of everything, the chosen ones, right? This is the idea. Now, obviously, many astronomers and physicists came after Copernicus, and they developed his theory from Kepler through Galileo and Sir Isaac Newton. But it was Copernicus who was the first who allowed us to understand that we are not the center of everything. And this is why we cherish Copernicus so much. Obviously, because not only because of the scientific revolution, but the revolution that we had to accept the fact as humans, culturally, religiously, that we are not the center of everything. We are not the chosen species in any way, right? And obviously, many contemporary astrophysicists and physicists came after Copernicus, from Einstein, Hubble, Vera Rubin, and Stephen Hawking. And many Polish astrophysicists contributed to the way that we see reality now, from Bogdan Paczyński through Aleksander Wolszczan, and recently Sławomir Uznański, the second Pole that will travel to space, one of the new astronauts from the cohort of European Space Agency. Now, what is left from Copernicus and what we cherish so much in contemporary cosmology is called the Copernican principle. And it's exactly about the fact that Earth is not the center of the universe, and we as observers, we don't occupy any special place in the cosmos, right? Now, let's see what it actually means. This is the comparison of scales. And in order to do so, I think I need some help with the... Start exploring is one, but then we need to, maybe if we stop this view, right? Yeah. Okay, it's fine. I'll handle from here. It all works. No, it's all good. I can work with this. So what you can see here is the different scales, right? This way, we can see the humans, the dinosaurs, and the concept behind this is to show you that we are not the center, not only of the planetary system, our solar system. As you can see the scales throughout the universe. Oh, there are some stars waiting for the red giants to come up. Maybe some nebulas now. And even waiting for the galaxies. Here they are. And as you can see, this is the universe. Far different from what we would have imagined like 500 years ago in the times of Copernicus. Let's go back to Madrid. Still stars. Italy, no. And only here we are, humans, right? And the dodo birds, which are extinct. And I think it's not maybe it's not an accident, I think, that we are presented next to dodos if we don't change our attitude. Anyway, let's go back to the presentation itself. But not from this slide. Okay, so we are here. Now, let's do it once again. We are here, but actually, we are here, right? But we are here, but we are also somewhere here. And the Milky Way itself is somewhere here, one of the around 60 galaxies that form the local group of galaxies. And the local group is somewhere around here. And on a large enough scale, you'd see that the universe, from a cosmic perspective, looks more or less like this. It's filled with galaxies, millions, billions of stars, and billions of planets around those stars. And when we think of the Copernican principle, that we are not the center of everything, and in no way we are the chosen observers, the question that we could actually ask ourselves, and the question which is valid and makes a lot of sense is there other life? Right? Because if we are not chosen and there are billions and billions of stars, why not? And there's a very easy way to calculate or at least estimate whether there is life not only in the universe but in our galaxy, and also if this life is actually intelligent and maybe we could communicate with this life. And some of you most probably know the way how to do it. It's called the Drake equation. And the Drake equation is an equation that allows us to understand, estimate how many alien intelligent civilizations are there exactly at this moment of time while I'm speaking and we are discussing here in Madrid. And it's an equation which is full of different factors. Some of them we know, some of them we are vaguely estimating. So N will be the number of intelligent civilizations exactly at this moment of time in our galaxy. Now, R is the average star formation in the Milky Way. F is the fraction of those planets who will actually, is the fraction of those stars who will actually have planets. Now, N is the fraction of those planets who are capable of hosting life. F is the fraction of those planets who will develop life. Fi is the fraction of the developed life, which is actually going to be intelligent. Then we are going to multiply it by the fraction of the intelligent life, which will be able to communicate. And finally, we will multiply it by L, which is the lifetime of a civilization. As you can see, we are discussing from, let's say, 1945, if we are capable of destroying ourselves. First it was the atomic bomb, now we are discussing the climate change. So you can see that once intelligent civilization emerges on a planet, it's not given that it will last forever. So this is why we also have L in this equation. And we will go through the equation now together, and hopefully we will see if there are, or can we at least estimate if there are any intelligent civilizations at exactly this moment of time in our Milky Way. And some of the numbers, because I'm an optimist, some of the numbers are very optimistic, some of them not really. Let's go through those numbers together now. So the average rate of star formation in our galaxy is very optimistic, and it's around 7. So after being optimistic, let's be a bit pessimistic now. So let's assume that around half of them is going to have planets. This is very pessimistic, but let's keep going. Now, looking at our solar system, 2 of the planets should be able to sustain life at some stage of the evolution of the system. Of course, there are more, there are moons that should be also capable, moons around different planets that should be capable of hosting life, but let's keep it pessimistic, and this number will be 2. Now, the estimated number of planets where life will develop, looking at the way the life developed here on Earth, is going to be 0.13. Now, a very pessimistic number. Only 1 in 1,000 of this developing life is going to be intelligent. 1/10, let's say, is going to be capable of communicating, and the average lifespan of a civilization, also quite pessimistic, let's assume it's going to be 10,000 years. And if we multiply all those factors, and remember this is just an assumption, but kind of based, some of it at least, on facts, we are going to receive the final number of alien civilizations at the moment capable of communicating with us. Quite a nice number, right? 23 intelligent life civilizations in the Milky Way. Obviously, this is kind of mind-blowing, specifically for a young astronomy student around 19 or 20 years old. And this is why I was in Torun around 15 years ago, developing this cosmic perspective on reality, understanding that I'm not the chosen one, nor my parents, nor my mom. And this is the type of things you would really want to talk with someone, you know, because it's about the core of who you are. And other than few colleagues, you're absolutely not capable of discussing this with anyone. And in a way, astronomers, physicists, we become lonely because we have no way to communicate and to discuss philosophical aspects of what we develop and how we do science and what we find within science. Now, this is why, still being a student, with my friends from the Faculty of Arts, I started the Institute B61, a non-profit research institute connected with the Nicolaus Copernicus University in Torun, where we work on art, translations of science, which are focused on the philosophical implications of contemporary research. And we try to find a way how to communicate with people and how to make science more understandable. And obviously, people have done it for years, because now you all know how an atom looks like, right? It's a planetary system. And this is not a surprise, because when people think and conceptualize abstract ideas, they tend to think with metaphors. Like, people think that time is money. And by this, I mean I've invested a lot of time to be here today, or you've invested a lot of time to spend this time with me. Or maybe if I would have a disease, I would think of, let's say, a flu or COVID attacking me. This is the way that we conceptualize abstraction, mostly scientific abstraction. But as we all know, in the beginning of the 20th century, something happened that doesn't allow us to conceptualize science this way. What happened was quantum physics. And quantum physics is not about metaphors which are derived from the reality that surrounds us. You can no longer think or understand that an atom is actually a small planetary system, because it's more like a Schrödinger's cat, an animal which is dead and alive at the same time. And in order to do so, we as humans, we need to learn how to create images, how to create different imagery than the one that we see in the surrounding world. So no longer can we speak about quantum physics, astrophysics, cosmology, like Copernicus did 500 years ago. Now we have to develop new ways of understanding science, and this is what we do at Institute B61. And as the basis of our art and science interventions, we are working with cognitive scientists, and let me now tell you why. I don't know if you ever heard of the Lion Man and the importance of the Lion Man. The Lion Man is a sculpture from around 40,000 years ago, and it is the first ever representation of abstraction. Before the Lion Man, what you would find, the type of art you would find, would be maybe a print of hand in a cave, or maybe the representation of the stars. But the Lion Man is the first time an artist, or the person who created the Lion Man for the first time ever summoned a creature which does not exist in our world, right? It's a lion and it's a man. That person knew what a lion is, and then that person knew what a human is. And at some point in time, our brains, more or less 40,000 years ago, gained this ability to blend concepts that we learned through daily experience. And this is the leap that allowed us to separate ourselves from animals. Or we are still animals, but with a very different mental capability. We are able of creating abstraction. If you think of an angel, it is exactly like a lion man. It's just a man with wings, right? Two concepts that we learned. And if you think, you can see the two mental spaces of a lion, a space of a man, and then we blend and we create the Lion Man. And if you look at the Schrödinger's cat, it's the exact same mental process that allowed Schrödinger, when he was writing to Einstein, trying to denounce the quantum mechanics, that allowed Schrödinger to imagine this situation. Schrödinger knew how a cat which is alive looks like. He knew how a cat which is dead looks like. And then his brain was able to create this abstract situation. And what we do in Institute B61, we try to follow this process, and we try to build immersive environments, and we invite people to these type of environments. So basically, we blend the artistic interpretation and the scientific theory and create performances, immersive performances. And for example, a main sequence star, which is the moment in which our sun is exactly at this moment and is burning a lot of hydrogen in its core, was imagined by an artist like this. So there is a group of people which enters a small room, heavily packed with people. The room is filled with paper, almost like 1 meter of shredded paper. And then when the paper goes up, and with the usage of very strong stroboscopic lights, the whole room starts to move like a slow motion movie, almost exactly like a photon trying to get out of the core of a star. So obviously when people get out of this experience of a main sequence star, they remember that the core of a star is a place which is extremely hot, extremely dense, extremely energetic, and it's full of absorption and emission of light. So this is the way you can actually understand the core of a star, other than through complicated equations of thermonuclear reactions. We were lucky enough to get a patent in the United States for this type of explanation of the core of a star. And obviously Institute B61 was created 15 years ago, so we've worked with a lot of different environment and artists. This is an artistic representation of infinity, famous words of Carl Sagan, who said that there are more stars in the universe than there are grains of sand on Earth, a kinetic sculpture. Then a planetary nebula. One of the artists imagined that it can be presented as a cotton candy, and or a black hole can be. This is from when the Institute presented a performance in India. A man can be crossing a river, showing up, and now let me show you a short video, because it's very hard for me to speak about immersive performances which are very experiential. So I guess I have two short videos to show you, and those are very immersive experiences. Let's go. This performance is called The Evolution of Stars. This one was done in Wrocław when Wrocław was the European Capital of Culture in 2016. People would follow the path of the evolution of stars. Recently, the same performance was presented in India during the Kochi Biennale. 5 billion is a lot, right? So we shouldn't have to worry. A statistical man lives around 73 to 78, depending on the country.
I have attended a few performance, immersive, experiential things, but such a beautiful story.
And we will now guide you through the evolution of stars.
I really like the idea that art is connected to science.
$5 billion years have already passed since its creation. There are 5 billion more before the destruction of the Earth. Okay, back. But there's a variety of places where we do the performances of Institute B61. The biggest and the most challenging experiences were done using trains and platforms. So we've established a train that would go around Poland, a train inspired by the Large Hadron Collider, where we would rent almost 10 cargo wagons, and the artist could do from video mapping, performances, to a variety of different experiences. And the biggest ever project that we've conceived was called the Cosmic Underground. It was a train that went through various parts of Europe, from Tallinn to Portugal. It would go basically through the Baltic states, Poland, and then we would establish it again in Portugal from Lisbon to Guimarães, which was then the European capital of culture, because the project was about taking international art and international festival to European capitals of culture, but also European capitals of nothing. So places which have train stations, which will never afford a huge international experience. And the Cosmic Underground lasted for more than 2 months. It involved around 40 different artists, scientists from different countries. And let me show you now a short video of the Cosmic Underground.
Space all over the place. It's cosmic underground. Time and space all over the place. It's cosmic underground. Inexplicable, individual, unforgivable. I forgive so much living. It's unconditional, unavailable, and unsustainable. Understated, don't know which way to go. 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 I choose to get this off my chest, cause how the fuck else would they get the message? Choose to get this off my chest, cause how the fuck rain just like I got. It's a full moon out tonight, but if people here just feel alright. It's a full moon out tonight, but if people here just get uptight. It's a full moon out tonight, but if people here just feel alright. All of you party people, put your hands in the air. Y arriba, la 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 la. All of you bigger people, put your hands up in the air. Let's pump this, let's pump this. Pump the jam, pump it up till your feet are stumping. Pump the jam, pump it up now. Pump the jam, pump it up till your feet are stumping. Pump the jam, pump it up now. Pump the jam, pump it up till your feet are stumping. Pump the jam, pump it up now. Pump the jam, pump it up till your feet are stumping. Pump the jam, pump it up now. 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 Pump it up now.
Now, obviously, this method of creating scientific imagery is not only good for immersive performances, but also to create, for example, video art. And I will show you a couple of videos from the Evolution of Stars series. The White Dwarf.
When the fusion reactions in the red giant cease, it sheds its outer layers and the gigantic force of gravity in its center overcomes pressure and forces atoms into such a density that they are stripped of their electron shells. In this way, the core of a star, similar to the Sun, turns into a white dwarf, becoming the last stage of the evolution of stars. Over billions of years, the white dwarf will slowly lose its heat, until it becomes a black dwarf, which we are not likely to live to see, being limited to our earthly shells.
One more.
To the simple human mind, it is difficult to imagine that almost 14 billion years ago, more than 1 billion galaxies, each containing more than 1 billion stars, were contained in an infinitely small and infinitely dense point, many times smaller than a grain of sand. This infinitely small and infinitely dense point has been called the initial singularity. Indeed, it is an infinitely singular singularity. When such nothing gives birth to such everything, in such a Big Bang. And if the Big Bang is just a hypothesis, in such a case then, what is not a hypothesis?
Continuing this theme of different ways how we can use the method of cognitive blending to create art and science, we've been invited to create one of the elements in the Polish Pavilion during the expo in Dubai. It's centered around the understanding of the cosmos, and the piece that I loved the most was a piece with the local fashion designers from Inowrocław and Włocławek, who created spacesuits of astronauts coming from Włocławek region in Poland using Polish faience, trying to address this idea that whenever we think of an astronaut, we see a white spacesuit with an American flag. So this piece was a lot about the colonialism of the imagery, that the way that we see astronauts is basically either they are Americans or they are Russians, right? So this idea was to inspire kids like 7, 8, 10 years old that you can actually dream of going to cosmos and you don't have to wear that white American flag type of suit, because you can be from Włocławek in Poland or anywhere else and you can still go to space and you don't have to. At least that's what we would like, and that's what we would like the universe to be or to belong to everyone and not only the ones with power. Now, Casino Copernicus is the exhibition that we have here in the planetarium. It's also dedicated to kids, however, there are elements, each of the games, because we've created 6 arcade games, has a twist. So, for example, you can become a terraformator. You go to different planets, you turn the planets into concrete. They are full of aliens. However, the aliens don't attack you and you cannot die. But the thing is that once you turn everything into concrete, it becomes very boring. And then off to another planet, concrete, boring, and so on and so on. Or the space junk, where you basically go out of your spaceship, but the orbit is so full of space debris that it's very difficult to come back to your ship. The games were first presented in Spain during Sonar. if you will have some time, you can obviously try. The exhibition opens tomorrow, but still today it's possible to give it a shot and try to terraform some planets. Now, the evaluation, obviously, as a scientist, I always tend to evaluate even art. And but the thing is that what we do a lot of the times receives critique in the form and in the words saying that the experiences that we create are euphoric and mind-bending and sometimes life-altering. And I say this not because I want to brag, but because I believe that in a way we were able to achieve this idea of introducing the cosmic perspective to our fellow colleagues, to my mom, to my girlfriend. Those situations of contemporary science are often so mind-bending that only through skin a regular person can understand them. What I really believe is one of the human rights is the access to knowledge. And obviously, one way is to learn through equations, to study extremely hard. But this is to become a scientist. I believe that as scientists and science communicators, we have the obligation to make at least the philosophical implication of contemporary science available to a wider public. And just a final note about who is the wider public. This is the representation of a white dwarf from an immersive performance that we've done at the Evolution of Stars. One of the artists imagined the situation of a star which is like in the last stage of its life, and obviously the inspiration is the Pieta sculpture. You can see the Holy Mary holding the Christ. And when we first introduced this performance in India, one of my friend curators who's from Tamil Nadu came to me and said, "Why? But why Death of a Star is so sad? Why do you portray and why do you think it should be sad?" And he later then showed me the way that some in Tamil Nadu say goodbye to their friends. So basically, Savukutu dance is a way of putting yourself into ecstasy rather than, of course, happiness or anything of this kind. But the final thing that I want to say is not only should we do science concerning our cultural differences, that's one. Our equations will always be the same, but our metaphors will be different. And the way that we communicate science also should be done in the local context. It's absolutely impossible to take a Carl Sagan book, translate it, and expect the metaphors to work for Indians or any other culture. If it works, it's by accident. We should really decolonize, in a way, also science communication concerning the communities that we work with, and we should invite the communities to create the metaphors and science communication, art and science with us. Thank you so much for your time, and yeah, let's have some questions if you have any.
Thank you very much, Jan. Si queréis preguntar en español o en inglés, como prefiráis. Si es en español, pues le traducimos. Levantad la mano simplemente que quiera alguna pregunta, alguna cuestión.
Yes.
Why the name of the institute is B61?
Yeah, thank you for this question. That's a great question. First of all, it's by accident. That was the name of the first ever place that we've done the B61. It was a very huge military fort. But on the other hand, I've learned that B61, by chance, it's an atomic bomb, which I don't like. But on the other hand, B61/2 is the planet that the Little Prince is coming from. So I thought it's nice to have an element of the Little Prince in the name of our accidental Institute B61.
Thank you very much.
Okay, thank you very much for your presentation. I'm really wondering, or maybe you have wondered too, why the universe pattern is so similar to our brain patterns with the neurons, the space between neurons, etc. In your performance, have you ever tried to represent this kind of similarity? Because at the end, you create this with your consciousness. That is really the pattern. You interpret the universe through a pattern that is very, very similar to the universe. I mean, this is philosophical, but maybe you have some answer to this.
Yes, I do, and I think it's there is a strong temptation to perceive it this way and to perceive the similarity between the small scale and the large scale. However, I tend to think it's the same trap as to search for the solar system in an atom and to do the other way around. So even though it would be very plausible for us to see some, and this is the natural way, we are animals that try to make sense out of everything. And what you're saying would actually make sense. But I'm not a person who believes that much in senses, in structures and patterns. However, maybe that would be very useful, and at least as a carrier and a metaphor of not being, the Earth not being so important and having different scales. That's a very nice metaphor, of course.
You spoke about decolonizing science and science popularization. Could you expand on that?
Mm-hmm. Of course. As I was trying to explain, the way that we understand equations, we understand them through metaphors. On the qualitative level, we use metaphors. And we as humans, we share some metaphors, the ones that are based on our, let's say, gravity, for example. So when you want to say that you're happy, most of the time you would say you're up. And when you're down, it means that you're very sad. And this is a type of metaphor which is spread across cultures. But if we are talking about more complicated stuff, then we tend to use metaphors which are based on social patterns and social behavior. And most of the way that we explain contemporary physics, quantum physics, and the way that we communicate it is using one type of metaphors, basically Western metaphors, and the metaphors which are based in our social behavior. For example, this idea that there is a cycle in the universe is far better explained through metaphors grounded in Hinduism than in our Christian religion. Obviously, for us, everything has a beginning and an end, and there is a judgment, and that's the end of everything. And most probably the universe doesn't look like this at all. Maybe there are cycles, maybe there are multiverses, and so on. So even if you're trying to figure out something new, it's always nice to go out of your metaphor bubble and the way that you think. And obviously Einstein was a person who used a lot of thought experiments and metaphors. Obviously all of them were grounded in his cultural experience. So it's extremely important to have diverse teams of scientists, also because we don't know exactly how creativity works and the moment of creation. And once again, equation and mathematics is universal. We all share this abstract language of equations. But the way that we construct the equations and how we are guided to construct a certain equation, for a lot of the times still is well, for cognitive scientists is a mystery. So it's extremely important to have diverse input from scientists, but also from science communicators. If you go to the different part of the world, you'd want your audience, first of all, to understand, but also to feel invited and co-create and participate in the understanding of our common knowledge, which then becomes our heritage as earthlings, not as nations.
I've got some question for you. What are your next plans? I mean, in terms of new experiences and so on.
We are going to show the evolution of stars videos in Cyprus with the Larnaca Biennale. It's a really nice art festival in Cyprus. Then I'm going to Lublin, a city in eastern Poland. We are working with the European Space Agency on a project presenting the overview effect and the way that some astronauts see the Earth from space. And then maybe at some point I will rest a bit, right? That's a nice plan. Yeah, and that's it. The daily life is so interesting and full of surprises. We will work at some point, obviously, for the next expo in Japan, and I'm really also looking towards that experience in a completely, again, different culture and interacting with people who perceive the world in a completely different way.
Because you're now working in Portugal, right?
Yes, yes. I work...
How long are you going to be there?
In Portugal, just a couple of days, to be honest, and then I'm off to other exhibitions, and I try to be a cultural researcher and a scientist, but in a different way than I think this is my background as an astrophysicist. I try to gather data, I try to do, and then I try to synthesize. And a lot of my friends at the university, humanists, like from the core, they do the other way around. They first create the theory, and then they create matter. So I'm a type of person, still a true scientist in that matter. I try to experiment with reality.
Okay, thank you very much. Do you have any other question? Yeah.
Thank you for the very interesting talk. Given the last quotation by Heisenberg, somehow it says that science is meant to achieve a full objectivity in its approach to the world, whereas art is completely, or not, I don't know if completely, but much more subjective in its approach to the world. In what degree can science and art converge, or are they basically complementary, or can they converge in their vision of the universe, of the world? Or
I think you said it very well, that they are on completely different parts of the spectrum. One trying to be extremely objective, the other one being subjective and valuing that subjectivity. Art is basically proud that it's subjective, right? But at the same time, they are both speaking about reality. And I think it's Picasso who said that every type of art always starts with reality, and then only it becomes subjective. So I think both of them are talking about reality, but you know, obviously, science tries to take out the human element, but the real question is what is left if we, because it's easy to say I can take someone of the equation, but if you are the scientist, or if you are the person, and it's your life that you're supposed to take out of the equation, a lot of the times you would turn to art for that subjectivity, or in order to be able to communicate with other people. And I think this is, well, we are humans, we are human beings, we live as, even now, during this gathering, obviously we are having a meeting which is important for some are bored, but this is what we live for. We tend to come together, we tend to speak, we tend to communicate and understand. And I think art is far better than science, right? Rather than discussing my state of emotions right now, I can be showing you some images, some art, and we are communicating, even though we see each other for the first time today. At some point, maybe the way that we see the universe aligned for a couple of seconds. And I think this is what art is and why it's so valuable to do art, also based in science, because I think science has a very unique way of understanding reality and also understanding who we are as humans. So it's a hard question, that's why I was so...
Any other question? Or... Okay, thank you very much, Jan. It was a pleasure to have you here. Gracias a vosotros por venir también. Y nada, invitaros a que si queréis ahora echar un vistazo a las máquinas, bueno, están aquí a la salida un poquito, tenemos unos minutos para que podáis mirarlas, si no otro día, e invitaros a las siguientes conferencias de nuestro ciclo, que ya el jueves que viene tendremos otra sobre todo lo que nuestro patrocinador, en este caso Airbus. Vosotros sabéis que pertenecemos al Ayuntamiento de Madrid, pero tenemos un patrocinador también que es Airbus, la compañía que también tiene una parte aeroespacial muy importante, pues nos van a contar todo lo que se hace, todo lo que están haciendo en el terreno aeroespacial. Y bueno, pues nada, muchísimas gracias y hasta otro día. Gracias. Gracias, Jan. Thank you very much.
Thank you so much. Gracias.